So these all are the four methods of networking the pipe in a city. So each method has its own advantages and disadvantages. So each method, to select a particular method, we need some technical guidelines, we need the pattern, we know the topology of the particular place or the city where we are going to go for the water supply system. So the first one is a dead end system. Dead end or tree system, and the another name of the system is tree system. So in this is a very old method. So normally old cities, this kind of system we are following. Okay. So we have the main pipe system, and then from the main pipe we have the branch, submain. From submain we have the branch. So with the main and the submain or the branch will be controlled by the cut-off wall or control wall. So this will be a pipe network along the side of the road. So as I said earlier, it will be applicable for old cities. So what are the advantages? Relatively very cheap. So because we are going to lay only one pipe and we will get the supply. Whereas in other system, for example, grid iron system or radial system, we need to have more pipelines. So only it will not be connected to the consumer alone. It will have ensure that circulation of water and all. So determination of discharge and pressure easier due to less number of valves. The main disadvantages, due to many dead ends, stagnation of water occurs in pipes. Because of that, there is the large possibility of water contamination. Radial system. So another one is the radial system. So in radial system, we have a main pipeline in the center of the city. From that center of the place where you are going to, then from there you will have the distribution reservoir. For example, here you have 4 distribution reservoirs. So from this distribution reservoir, we have the branches, and then from the branch you will have the submains. Okay. So the water pumped into the distribution reservoir kept in middle of each zone. So we will identify a central place of the each zone. From there, the water will be supplied in such a way that their equal distribution is take place. The supply pipes are laid radially ending towards the periphery of the city. So what are the advantages? It gives quick service. Calculation of pipe size is very easy. Next one is a grid iron system. So in a grid iron system, it's suitable for the cities with rectangular layout where the water mains and branches are laid in rectangles. So we will have the main pipe. From the main pipe, we will have the submains. From the submain, we will have the branches. So as you know that we have cut off, all control valve should be there. So we have the main line. From the main line, it will be divided. So in the last system, we need more number of distribution reservoirs because of zonation and all. It is very good. But in this case, we have one main pipe through which you can connect all the submains and the branches. The advantage is what is kept in good circulation due to the absence of dead end. So because of that, we can ensure there is no stagnation of water, there is no contamination because of that. In case of breakdown in some section, water is available from some other direction also. So it will be very easy for maintenance, or any breakdown or any problem occur, it will be easy to maintain. And as our objective in water distribution system is, we should ensure there is no breakdown and there is no supply cut. Okay. Disadvantages: exact calculation of pipe are not possible due to provisions of valve and all branches, because it have all the way you have pipes and other things. So that calculation have its own disadvantages. Another one is the ring system. So ring system laid along the peripheral of the road, main branches of the main. So you have the main pipes in the outskirts of the place, city or the zone where you are going to go for the supply. From the main, you have the submain. Okay. So from the submain, you will go for the control valve and things will be there. This system also follows a grid iron system with the flow pattern similar in character to that of dead end system. So determination of size of pipes is very easy. So advantage is water can be supplied to any point from at least 2 directions. This is the main advantage. Suppose any breakdown take place or any maintenance if you want to carry out, it will be very easy to with the supply. The next one is the method of water distribution. Normally the people will get confused between the water supply system and methods. See, actually system means dead-time system, grid-time system, like that. What system we are going to follow? Water method of water distribution is how we are going to, or which method we are going to adapt. In this case, we have three major classification. One is the gravity system, pumping system, combined gravity and pumping system. It's purely based on the three categories. One is the source, then your treatment plant, then your distribution unit. Suppose we will discuss one by one. The first one is the gravity system. So we have the source. Suppose you have the treatment plant here, then your supply distribution supply consumers are here. Then you can go for a gravity system where there is no need of pumping. By using gravitational force, the source to the treatment plant, from treatment plant to the people or consumer will be achieved. It is a most reliable and economical distribution system. The water head available at the consumer is just a minimum required. The remaining head is consumed frictional and other losses, suitable when source of supply is sufficient height. So the only challenge here is your source and your treatment plant should be in the elevated places with a sufficient minimum required pressure. So actually the minimum required pressure for a particular water supply system, for example, it is a 3-story building, we have to maintain 2 kg per centimeter square. And then if you ask me what is the velocity, minimum velocity we are supposed to maintain is 0.6 meter per second. Velocity should be maintained in a distribution system. If you are able to provide such amount, then it will be, you can go for a gravity system. So these values, as I said, for velocity it is 0.6 meter per second, and for pressure it should be, for example, for 3-story building it should be 2 kg per centimeter square. These all are given by the CBHEO guideline and the urban ministry. Another one is the pumping system. The treated water is directly into the distribution main outstoring. So for example, it's very simple. So you have your source here, and then your treatment system here, then your consumer is there. So it is in the opposite to the first gravity system, where you have to depend on the fully pumping system. You have to pump this from the source to your treatment plant. You have to pump the water from treatment plant to your distribution system. You have to pump the water. So it is the case. So it is also called pumping without storage system. High lift pumps are used. If power supply fails, complete stoppage of water supply, the method is not generally used. Nowadays we are not going for this method. It is obsolete. Combined gravity and pumping system we can see in most of the common places because of topography of the particular place. We supposed to go for a combined gravity and pumping system. It is the most common system. The treated water is pumped and stored in elevated distribution reservoir. From the distribution reservoir, say for example this is the source of water, so it will be treated, then it will be stored in a elevated reservoir or a distribution reservoir or service reservoir. From that the water will be supplied to the crop. So the minimum required pressure and head will be maintained. And then for firefighting it will be easy and economical, it is efficient, and it is also a very good reliable system. Thank you.